some more questions about the effect of a scale factor increase on area and volume. In this case here we've got a martini glass. It's conical in shape, and we're asked to work out the capacity of the glass when it's brim full to the top. So being a cone, the formula is V equals 1/3 times pi r squared h. This has got a height of 10 and a radius of, it says 6 centimetres. They're not marked in, we'll put it in here. So 1/3 times 3.142 times radius squared, 6 times 6 times the height is 10. Now, I've worked this one out beforehand. It works out to be 377.04 centimetres cubed. We were asked for capacity, and that really means how much liquid could we put inside it. And we usually measure liquid in millilitres or litres. Millilitres is most appropriate here, and each millilitre takes up the same amount of space as 1 centimetre cubed. So 377 centimetres cubed is 377 millilitres worth of liquid. The capacity equals 377, we'll just round it off to 377 millilitres. Now we're asked to use our knowledge of scale to predict the amount of liquid that's in the glass if it's filled to half its height. Now you'll notice this small cone here is exactly the same shape as the large one. It's got the same angles and everything's in proportion. So it's just a scaled down model of the big cone. It's in fact half its height, all its dimensions will be halved. Now we're asked to use our knowledge of scale here. So the scale factor involved is a half, or we could write it as 0.5. Now that means when we talk about its volume, the volume of the small one isn't going to be half the volume of the big one. The volume of the small one is going to be multiplied by the scale factor cubed. So its old volume, 377, times by 0.5 cubed. Let's do it on the calculator. So we've got, picking up a bit, 377 times by 0.5, and to cube it I'll just times it by itself 3 times. And I get that the new volume of it is 47.125 centimetres cubed, or the amount of liquid will be 47.125 millilitres. And now we're asked to confirm this result using calculations. In other words, what we're going to do is we're going to actually calculate, use the dimensions of this to calculate its volume. Now, I'll just draw it again here. Now, the little one is a half size model of the big one. Where that was 10, this one is 5. Where this one was 6, this one is 3. So we can work out its volume using the formula. Times radius squared is 3 times 3 times height of 5. And I'll just do this one on the calculator later too, so it's 1/3 times pi 3.142 times radius squared, 3 times 3, times the height of 5. 47.13. And you can see that these two answers are more or less the same. Slight inaccuracy there. We did some rounding off earlier and bits and pieces, but more or less we've got the same answer. And a couple more questions here at the bottom of the page. A flag's got an area of 3.5 metres squared. And we have to find out what factor must the dimensions be scaled for the flag to have an area of 6 metres squared. Now remember that area increases with the square of the scale factor. So in other words, if we were to start with that 3.5 square metre flag and multiply it by some scale factor, it's really the scale factor squared that we have to multiply it by to come up with the 6 metre larger model flag. Now our job is to solve this equation. In other words, shuffle it round until we can find out what S equals. Now, the way we could go about this is, first of all, let's see if we can get rid of the 3.5. We've got 3.5 times S squared equals 6. You can get rid of that 3.5 by doing the opposite of timesing by 3.5, which of course is dividing by 3.5. So that means that S squared equals, dividing this side by 3.5, you're left with S squared. We must also divide this side by 3.5. Now that means that S squared equals, and I'll just find out, 6 divided by 3.5 is 1.714. But that's S squared, and I want S. Now to find S, I'll need to take the square root. So that means S is equal to the square root of 1.714. Take the square root of this side, I'm left with S. Take the square root of this side, and I'll find out that S is equal to, and I'll have to go into my different model. Here we go. I want the square root of my answer. Square root of my answer is 1.309. Let's make it 1.31 to 2 decimal places. So, in other words, if the flag had the initial area of 3.5 metres squared, and if its dimensions are increased by a scale factor of 1.31, its area will end up being 6 metres squared. Now the last one is a similar question. The drum's got a capacity of 50 litres. By what factor must its dimensions be scaled for it to have a capacity of 200 litres? Now remember that volume increases with the cube of the scale factor. So it's not just a matter of multiplying 50 by some scale factor to come up with 200. We multiply it by the scale factor cubed. 50 times whatever the scale factor is cubed is going to equal 200. Now if I can solve this equation and find a value of S that makes it work, I'll have the scale factor I need. Now, first of all I need to get rid of the 50. Now that's not too hard. At the moment it's 50 times S cubed. So what I want to do is do the opposite of timesing by 50. Divide both sides by 50. S cubed equals 200 divided by 50. Can almost do that in my head. 200 divided by 50 is 4. So S cubed equals 4. I want to find the number which when multiplied by itself 3 times equals 4. I'm going to need to do this on my calculator. On the Casio calculator under your maths tab here, you'll see this one here. I've got the little symbol there and I can do the cubed root. To find out S, what I'm going to do, the number which multiplied by itself 3 times to equal 4, if I take the cubed root of both sides, it's the opposite of cubing it. A bit like taking the square root of both sides is the opposite of squaring it. And what I'm doing is I'm finding the number which when multiplied by itself 3 times equals 4. So it's got a little 3 just here. the cubed root of, I can just get in there if I put a 3, the cubed root of 4 finds the number which when multiplied by itself 3 times equals 4. And the number is 1.587. Well, that means S equals, I'll make it 1.59 to 2 decimal places.